All right, guys, I know this is long overdue, but I'm just so that you guys can review this weekend if you need to. I'm going to make a video on the graphs of sine and cosine. All right, so this is what a sine curve looks like. I mean, I'm sure by this point most of you already know, but we call this, what you see up top right here, this is one period or one cycle. So this up here, this is one cycle of sine. And then what you see down here are multiple cycles of sine, right? So we have this section, right? What I just drew is one cycle. And then we have another cycle, right? What do you notice about the cycles, right? The cycles are exactly the same shape. They're just repeated over and over again, all right? This makes sine a periodic function, right? A periodic function has a pattern, right? That repeats over a set period, right? The period is just the length of I guess time in a sense, right? The length of time or the amount of distance that it takes for one cycle to complete. After a period, right? After the length of this period, then you have a repeating pattern. And if you notice, the graph of cosine looks exactly the same, just shifted a bit, right? Notice now that this right here, this is one cycle of cosine. Right? If you were to like back up and look at the graphs of sine and cosine, they have the same wave shape, right? They go up and down, up and down, up and down, up and down. All right, but what differentiates them is when the cycle starts and when the cycle ends, right? A cosine cycle starts at the top, goes to the very bottom, and then ends back on top. All right, and then you take that shape and then you repeat it over and over and over again. The graph of sine starts in the middle, goes up all the way down, and then ends back in the middle. All right, so this is a graph of cosine, this is a graph of sine, all right? Or this is a cycle of cosine, and this is a cycle of sine, all right? Characteristics of sine and cosine functions, or graphs of sine and cosine functions. We have, for every function, an amplitude and a period. The amplitude is just how high or low it goes, all right? And that's always given by absolute value of whatever's in front of sine or cosine, right? So there's going to be a number in front typically. If you don't see a number, you just assume it's 1, all right? The period, like I said a couple slides ago, is just the length of time or the horizontal distance that a cycle is complete. And to find that, it's going to be 2 pi divided by whatever's on the inside multiplied by x. All right, so to graph basic sine or cosine functions, this is how I do it. I do it exactly in this order. I first find the amplitude and the period, and then I find the key points by multiplying the period by 1/4, 1/2, and 3/4. This is just because if you look on a unit circle, all right, this is where the numbers come from, right? On a unit circle, you get the graph of sine and cosine based on these ordered pairs, right? So you have an ordered pair here of 1, 0, 1 up here of 0, 1, and then we have -1, 0, and then we have at the bottom here 0, -1. And then notice that after every quarter of a cycle in a unit circle, we approach one of these values, all right? Now, we use these particular values just because, I mean, any point on the unit circle is valid. It's just they're not as easy to see. Like, you could very easily pick an ordered pair like 1/2, square root of 3 over 2. But, I mean, who wants to graph square root of 3 over 2, right? We pick the easiest ones, and those easiest points are the ones that are on the quarterly intervals of a unit circle, all right? And then you plot those points on the key... You plot the key points on the x-axis, you mark the amplitude, and then you match the sine or cosine pattern, right? Like I said, sine starts in the middle and then ends in the middle. Cosine starts at the amplitude and then ends at the amplitude. Or let's say it's reflected, then cosine is going to start at the bottom and then end at the bottom, and then sine is going to start in the middle, go down and then up, and then end back in the middle. All right, this is all going to make sense once I do some examples. All right. Let's start with something simple like this. Let's first identify the key information. Let's start with an amplitude, All right, the amplitude, again, is just the absolute value of whatever's in front of your sine or cosine function. And in this case, the number in front is 4. Absolute value of 4 is just 4. All right, so that means we're going to have a graph that's going to go up 4 units and then back down and go down to -4. All right, so highest is 4, the lowest is -4, and then you're going to have that pattern, right? Now let's find the period. All right, the period is given by 2 pi over b. In this case, b is the number inside being multiplied by the x. So we're going to have 2 pi over 2, right? There's a 2 in front of the x, which simplifies 2 pi. That means one cycle of sine is complete after pi units. All right, now what we want to do is find key points. All right, key points are going to be at 0, a quarter, a half, 3/4, and at 1 full cycle, right? So I'm going to multiply the period of pi by every single one of these numbers. Again, we use these numbers because we only care about the points at the quarterly intervals of the unit circle, right? So then we get 0, pi over 4, pi over 2, 3 pi over 4, and then pi. All right, because we don't have any horizontal shifting, what we can do is we can make all of these negative as well, and we're also going to have key points there, right? So pi over 4, I can make negative pi over 4. Pi over 2, I can make negative pi over 2. 3 pi over 4. Whoa, I'm going too fast, right? I wrote 2 pi's. I don't know why I did that. All right, is going to be negative 3 pi over 4. And then, whoa, hold on, arrow. Okay, and then pi is going to become negative pi. All right, you're going to see what we're going to do with this now, right? So I'm going to make a little graph. The amplitude is 4, so that means the highest we're going to go is 4, and the lowest we're going to go is -4. And I'm going to use these key points, right? So let me circle them, right? These 5 key points and the 4 negative ones, and we're going to use those to graph this function. All right, so I'm going to plot them on the x-axis. So I have a 0, a pi over 4, a pi over 2, a 3 pi over 4, and a pi. I'm going to do the exact same thing in the negative direction. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. All right, and sine always starts in the middle, and we started at 0, right? 0 is always where you're going to start. And then sine in this case is going to start in the middle, so it's going to be something like that. The pattern goes, it's going to go up at the amplitude, back down to the middle, all the way down to the bottom, and then back up to 0, right? So that is one sine cycle, all right? Then you want to go in the opposite direction, right? Make sure you have this exact same cycle. So it's going to go down, back to the middle, all the way up to the amplitude, and then back to the middle. So these 2 periods that you just drew should be identical, all right? And then it's going to go forever and ever in both directions. The rest of it we don't really care about, right? As long as you have that general pattern. All right, but that's really it. All right, let's try something similar here. All right, so I have -2 cosine of 2/3 x, right? So again, we're going to find the same information. The amplitude is going to be absolute value of a, so absolute value of -2, so 2. All right, so that means it's going to be at its highest 2 units and at the lowest -2 units. All right, but one thing to keep in mind with that negative, that means the graph of cosine is going to be reflected. All right, so you're going to have a reflection over the x-axis. All right, next thing we want to find is the period. Keep in mind it's 2 pi over b. B in this case is 2/3, so I'm going to do 2 pi over 2/3. And then when you keep change flip, it's going to be 3 over 2, 3 over 2, which is going to get you 3 pi. Whoa, hang on. 3 pi. Sorry. All right. And then we're going to have our key points. Again, to find our key points, we're going to go 0, a quarter, a half, 3/4 and 1, and then you're going to multiply the period by all of those numbers. Times 3 pi, times 3 pi, times 3 pi, times 3 pi. 0 times 3 pi is 0. 1/4 times 3 pi is 3 pi over 4. 1/2 times 3 pi is 3 pi over 2. 3/4 times 3 pi is 9 pi over 4. And then 1 times 3 pi is 3 pi. All right? And then once again, you want to make sure that you're plotting the opposite as well, just so that you have enough information to graph, right? The negative of this is going to be negative 3 pi over 4, negative 3 pi over 2, negative 9 pi over 4, and then negative 3 pi. All right? So now let's plot all of this information on the graph. All right? The amplitude is 2, so the highest is going to be 2 and negative 2, and then I'm going to plot these points, right? So 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and then 3 pi. And then you're going to go in the negative direction as well, negative 3 pi over 4, negative 3 pi over 2, negative 9 pi over 4, and then negative 3 pi. All right? Cosine starts at the amplitude. All right? So originally, it would start all the way up here at 2. Since there's a negative, though, you're going to start at negative 2. All right? So since you're all the way at the bottom, the only place to go for the bottom is up. Right? So then you're going to go up to 0, all the way up to the highest point, back down to 0, and then back down to the lowest point. All right, so there's one cosine cycle. Looks something like that. And then you're going to do the exact same pattern in the other direction. It's going to go up, and then down, and then down. All right, so then it looks something like that. And then we do the exact same thing in both directions, right? I want to repeat that pattern. All right, and then that's the graph of this function. All right, we can try the exact same thing here. Identify the same pieces of information. The amplitude is going to be absolute value of A. In this case, it's going to be 1/2. All right. Period. You're going to take 2 pi over whatever number's in front of the x. In this case, it's just 2 pi over 3. Let's find our key points. All right. To find our key points, once again, it's going to be 0, 1/4, 1/2, 3/4, and 1, all right, times the period, times 2 pi over 3, 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 and then times 2 pi over 3. So then we get 0, 2 and 4 simplified. This is going to become pi over 6. This is going to become pi over 3. This one is going to become pi over 2, and this one's just going to be 2 pi over 3. Again, you want to make sure you're plotting the negatives as well, right? You don't really have to write them down, just as long as you know where they're going to be on the graph. As long as you label it on the graph, that's fine. All right, unless we instruct you to, right? I think on the test, we're going to ask you to plot 4 points to the left, 4 points to the right, and list them. All right, so if we ask you to list them, you should list the positives and the negatives. All right, so we're going to start at 0, pi over 6, pi over 3, pi over 2, and then 2 pi over 3. And then you want to do the same thing in the negative direction. Negative pi over 6, negative pi over 3, negative pi over 2, and then negative 2 pi over 3. All right? And then 1/2 is the amplitude, so it's going to be 1/2 right here, and then negative 1/2 right here. All right, sine always starts in the middle, so I'm going to plot that point. Since it's negative, it's going to be reflected, so I'm going to go down then, right? Down, and then up, and then up, and then down. And then this is one reflected sine cycle, all right? And then you do the exact same thing in the other direction, right? So you go down, up, and then you go up again, and then back down, and then back down, and then back up. All right, so then we get this as one sine cycle. Another one, right? And then it goes like that, right? All right. Vertical shifts is if you add or subtract to the actual function, right? Adding moves the graph up, subtracting moves the graph down. How I would do these is I would graph the original first, and then shift the key points that you plotted up or down the appropriate number of units. All right, so something like this. Let's find the key pieces of information, right? The first thing I want to find is an amplitude. All right, there's nothing in front of sine, so we assume it's a 1, so the amplitude is 1. All right, the period is going to be 2 pi over whatever is on the inside. On the inside is 4, so it's going to be pi over 2. All right, and this one does have a vertical shift. This is going to be shifted up 1 unit. All right, and then now let's find our key points. All right, so again, I'm going to start at 0, a quarter, a half, 3/4, and 1. And I'm going to do times the period for everything. So times pi over 2, times pi over 2, pi over 2, pi over 2, and then pi over 2. All right, and then this is going to get us 0, pi over 8, pi over 4, 3 pi over 8, and then pi over 2. All right, and then now let's plot these on the graph. All right, make sure I have enough room. Okay, so I have 0, pi over 8, pi over 4. All right, make sure they're in the correct order. All right, and then pi over 2. And then you do the same thing in the negative direction, right? So negative pi over 8, negative pi over 4, negative 3 pi over 8, and then negative pi over 2. All right, this is sine, and sine starts in the middle. Oh, let me plot the amplitude, right? 1 and negative 1. And then since it's normal, right, there's no reflection, I'm just going to go up, like normal pattern, down, down, up, right? So there's a 1 sine cycle. And then I'm going to go in the opposite direction, right? So down, up, down. All right, so then that's another sine cycle. All right, so that's what the original graph would look like. Now what I want to do is move everything up 1 unit, right? Because we do have a vertical shift. So I'm going to take this point, move it up. Let me extend the graph. It's actually going to go up to 2 now. All right, take this graph, move it up to 2. I mean this point. Take this point, move it up to 1. All right, this point it was at negative 1. Let's move it up to 0. And let's move this point up to 1. So then in light green is what I have as the actual graph, right? And then it's going to go forever and ever like that. All right, do the exact same thing in the other direction, right? Plot the new points. All right, so then we have this now as the other side of it. And then it's going to go forever and ever in both directions, right? So in green is the actual graph that we're interested in, right? The blue is just there to guide us, right? But that's not going to be our final graph. It's the green one. All right, let's try the same thing here. Okay, our amplitude is going to be 1. Period is going to be 2 pi over whatever's on the inside. And in this case, what's on the inside is a pi over 4. All right, keep, change, flip. This is going to be a times 4 over pi. So that's going to get us just 8, right? Plain old 8, right? It's not going to have any other pi's attached to it. It's just 8. All right, and then now let's find our key points. All right, so we're going to do 0, a quarter, a half, 3/4, and 1 times the period. So times 8, times 8, times 8, times 8, times 8. And then we have 0. This one's just going to get you 2, 4, 6, and then 8. All right, pretty easy numbers, right? And this one shifts down, right? So let's go ahead and graph it, the original one, and then we're going to shift it down a unit. All right, so I'm going to have a 1, a negative 1, and then since we're going to shift it down, let me plot a negative 2. All right, so on the x-axis, let's plot the 0, the 2, the 4, the 6, and the 8. And then let me plot the negative 2, the negative 4, the negative 6, and the negative 8. All right, sine is going to start in the middle. So then it's going to go up, then down, and then up. So this is what one of our cycles looks like. And then the other way is just going to go in the opposite direction, right? It's going to look something like that. All right. But I want to move all of these points down 1. So down, 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 and down, right? And then do that for every single point that you plotted, right? Just to get an accurate graph, right? Every single point that you plotted should move down 1. All right. Lots of points that we're plotting, right? And then let's sketch the graph. It's going to look something like this. All right, and then it's going to go forever and ever in both directions. In blue is the actual graph, right? It's the one that shifted. In red was just there to guide us. Okay. Now, the trickier part is if you have a phase shift, right? A phase shift is another word for a horizontal shift, right? So it just changes where you start. So notice now the amplitude in the period, we find the exact same way, right? It's still absolute value of A, 2 pi over B. But this is if you have a number on the inside. So if I have a bx minus c, what it's going to be is the horizontal shift is going to be c over b. So you're going to take a number on the inside and then divide it by whatever's in front of the x. All right. The ones in this class are not going to have anything in front of the x. So it's just going to be the c value, right? Whatever moves it left or right. So to graph with a phase shift, it's going to be the exact same way as we did before. Just the only thing is that once you find your 5 key points, you're going to add the phase shift to that. All right. And I'll show you what that's going to look like. So if I have something like this, right, let's find our key information. We have an amplitude of 1, a period of 2 pi over b. There's nothing in front of the x, so it's 2 pi over 1, so just 2 pi. We do have a phase shift, right? There is a minus pi over 3. Minus means you're going to go to the right. All right, so you're going to add pi over 3 to your key points. So add pi over 3 to your key points. All right, so let me write out the key points. For 2 pi, it's going to be 0, a half, whoa, not a half, a quarter, 1/2, 3/4, and 1. And then I'm going to do times 2 pi all the way down, right? I'm not really going to show that process, right? This is going to get a 0, pi over 2. Right? I think by now we can kind of get the idea, right? 3 pi over 2, and then 1, all right? Now what you want to do is add pi over 3 to all of these points. So plus pi over 3, plus pi over 3, plus pi over 3, plus pi over 3, and plus pi over 3. Wait, hang on, this is 2 pi, sorry. 0 plus 2 pi is just, pi over 3 is just pi over 3, all right? Pi over 2 plus pi over 3, you need a common denominator. Between 2 and 3, it's going to be 6, right? So you're going to do times 3 times 3, and then times 2 times 2. So you get 3 pi plus 2 pi, which is 5 pi over 6, all right? Pi plus pi over 3, you're going to get a common denominator. So another one, times 3 times 3, and then we get 4 pi over 3. And then for 3 pi over 2 and pi over 3, right, times 2 times 2, times 3 times 3, and then you get 9 pi plus 2 pi, which is 11 pi over 6, and then 2 pi plus pi over 3, that's going to be over 1, and then times 3 is going to get us 6 pi plus pi, and so we're going to get a 7 pi over 3, all right? So we're going to take these values now, and we're going to plot them on the graph, all right? So we're going to have an amplitude of 1 and -1, right? Instead of starting at 0 now, we're going to start at pi over 3. Let me label that on the graph. So pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, and then 7 pi over 3. All right. To figure out the 4 points to the left of it, right, just think about how much is increasing each time. All right, so one thing that you can do is, since from 0 to pi over 2, right, you can think about it like this, right? From 0 to pi over 2, we're adding pi over 2. From pi over 2 to pi, you're adding pi over 2. From pi to 3 pi over 2, you're adding pi over 2. So that means to go backwards, you're going to subtract pi over 2. All right, so let me do that work up here. Right, so this is where we're starting. Our starting point is now pi over 3 and not 0. So that means from pi over 3, let's subtract pi over 2. All right, and then when you do that, right, times 2 times 3, this is going to get you negative pi over 6. So let me plot that, negative pi over 6. To figure out the other 3, just keep going backwards. Negative pi over 6 minus pi over 2. You can do times 3 times 3. And then you get a negative 4 pi over 6, which is going to simplify to negative 2 pi over 3. So we're going to get negative 2 pi over 3. And then take negative 2 pi over 3 and then subtract pi over 2, right? Times 3 times 3 times 2 times 2. That's going to get you negative 4 pi minus 3 pi, which is negative 7 pi over 6. All right, so negative 7 pi over 6. And then subtract again minus 2 pi. I'm sorry, not minus 2 pi, minus pi over 2. And then times 3 times 3. This is going to get you negative 10 pi over 6, which is negative 5 pi over 3. Negative 5 pi over 3. All right, so the phase shift is the kind of tedious one to get all of your points. Another thing that I showed you guys in class, if that made no sense to you, right? What I showed you guys in class is that you can also, from the key points, do the negative as well, right? Negative a quarter, negative a half, negative 3/4, and negative 1. And then times the period, so times 2 pi, times 2 pi, times 2 pi, times 2 pi, and then add the phase shift to that. So plus pi over 3, plus pi over 3, plus pi over 3, and then plus pi over 3. All right, you should get the exact same information, but let's just start by graphing this now, right? Sine starts in the middle. Our new starting point is pi over 3. It's not going to be at 0. But there's no reflections here, so I'm just going to go up, then down, and then up. So this is one of our cycles. All right, and then you go backwards, right? Then you go down here, then you go up right here, and then you go up right there, and then you go back down right there. So that's another cycle, all right? And then in either direction, just don't stop abruptly, just at least sketch out the other sides of it. And then that's the shape of that graph. Just to get this video out sooner, I'm going to stop it right there. You're going to see the next examples are pretty much the same thing. So yeah, I'll stop it there for this lesson. That pretty much covers all of the sine and cosine graphs that you'll need to know for your upcoming test.